Hi everyone, welcome to day 6 of my cloud series. So today we'll going to learn these topics. First, what is paging? Second, what is segmentation? Third, what is virtual memory? Fourth, replacement algorithm. Fifth, what is thrashing? Okay, so I'm going to my notes. So firstly, I will explain you the definition of what paging is. So it's a non-continuation of memory allocation. Okay, the main disadvantage of dynamic partition is external fragmentation is happening. So can be removed by compation, but with overhead we need more dynamic flexible optimal mechanism to load process in the partition, ideal behind paging. If we have only two small or non-condition free holes in the memory, say 1 KB, if OS wants to allocate RAM or 2 KB allocation, if possible, I must have memory space available 2 KB. What if we divide the process into 1 KB blocks? Paging is memory management scheme that permits the physical address space of a process beyond one condition. I'm going to explain you now. So what will happen, this is your process, and it is a logical address, logical address of a p1, and this is your process. So we are dividing each your process we are dividing a process by paging. We are calling this paging p1, p0, p1, p2, p3 in logical address, and it is equal page equal to frames in physical address, like in a RAM we divide equally, so there is no external fermentation will not will be happen. So this will be happening. So if you see these notes you will understand. And page table means nothing but it's storing logical page number and physical frame number. This 0 1 2 3, you're in logical numbers. So page 1 it's storing is there, and frame number where it is stored and upload. It's nothing but a page table. Logical address 04 bytes, it's like that. And if you can see, what is p is logical address and d is log a physical address. So through operating system context switching and everything is will happen, like translation lock asides buffer TLB, like that. So you can flush the TLB when the context switching occurs. If you see in TLB, if you see in that table, uh, page table, how if it is only for process 1. If process 2 will happen, then this will be not valid, this table logical address. And so what will do, assign a logical address one more. So there then we can then OS will understand, okay, this happened, this like, for I will explain through this example. If there is a diagram, if you see this is a PC CPU, and if you see p1's first c, like it will see if there is there, then it will hit and it will do. If not, then it will go to the page table and allocate that memory, and that it will happens. And after that there is we also assign address space identifier. So if there p1 and p2 will process will there, then also we can identify, and through we can do this all these things in paging. There is a paging hardware, so we can paging is the disadvantage of paging. There is more overhead, that's why for speeds it's slow. For speeding we use paging hardware with TLB. Okay, so now we're going to segmentation. Segmentation is nothing but dividing your program into segments, like your main program, your data, your div stack, everything in your different size of segments we divide. So it's like that. So in that we can say segment number and offset. The offset nothing but your frame number. Okay, so internal in paging and program. Now I will explain you this in this notes through. This is your like limit based. Through this we this will happen segmentation and all. So as important aspect of memory management that become unavailable with paging is a separation of users view of memory from a actual physical memory. So segmentation memory management technique that supports the user view of memory. A logical address space is a collection of segments. These segments are based of user logical memory. You can read these notes, so you can understand. Advantage of segmentation is no internal fragmentation will not happen. One segment has a continuous allocation, hence efficient work within segment. The size of segment table is generally less than the size of page table. Okay, you can read this. A disadvantage of external fragmentation will happen. Different size of segmentation is not good at the time of swapping. So nowadays modern system architecture provides both segmentation and paging implemented in some hybrid approach. Okay, we will jump to the next topic: memory, virtual memory. Okay, if I have like virtual memory, physical memory, and logical memory. So RAM plus swap area is equal to virtual memory. This is the mean. I have explained you if ready space, if there is like we have talked before, if there is a ready space, like that program is not in a swapping, that will be stored in a disk like that. So it's a swap area. So virtual memory is like that. So virtual memory is a technique that allows the execution of process that are not completely in the memory. It provides user an illusion having a very big memory. This is done by treating a part of second memory as the main memory. If you see there is a P1, P2, P3, and there page 1, page 2 has like that. So what will happen? Base always what will always will always what always will do, this page 1, page 2, page 3, if this is the page 3 and page 4 is important needed, then it will only run in it only allocate the RAM. Otherwise this will be in a swap pace, like in a disk, in a RAM. So in a disk, so you assume that your process is running all the process, but it is not. Always what will happen, the needed page is only working. Otherwise this not needed process it store in a disk. So you assume like your disk is so big, your RAM is so big, but it is not. It's but through this paging it's making a illusion you that your RAM is so big, like that. So you can read this, so you can understand this, how demand page works and all. Okay, so this demand page and all, and the head page for nothing but if it see this page is are present in a RAM or it present in a swap page, so that call is a page fault. Okay, how to handle it, you can read this. Now we can explain the different topic: page replacement algorithm. We will discuss page replacement algorithm. How first is FIFO, first in first out. So what will happen, if you see there is for 7012, so first will 7 will come in a page, then 0, then 1. After what will happen, 2 is come. So what will happen, first has first come, so that's why it all go out. So normally what will happen, if you see this the in this also, so types of people we will understand. Bloody anomaly is present in this case of LRU and optimal page replacement algorithm. It seems that the number of pages faults will be reduced if it is increased the number of frames. However, bloody fault in the place replacement algorithm, number of page faults will get increased with the increment number of frames. So what it is saying, if a number of frames increase, so your number of like first in first out will happen, but it's not happening. It's sometimes it's give more and sometimes it's get less, so it's saying like that only. Second is optimal page replacement. Optimal means we are, this is the best and best case and best algorithm, but it hardly and impossible to implement, because we assuming that we predicting the future that this page will never going to come one by one, like it's never going to come again. So we are assuming that page, but we can't like we can't predict future. So that's that's why it is impossible to implement. and list is recently used this for this optimal we can opposite, like we can, like we can assume that by future, like by past, how that which page is not repeatedly come, so we can that swap in space that page like that. It's saying like that. If you see optimal page replacement, first find a page that is never referred in the future, so it impossible. List recently used, when we can use a past as approximations of the near future, we can replace the page that has not been used for the longest period. Okay, now you understand what I'm saying. So how can be implement? There is a two stack or counter, you can understand by this, by reading only. And for this counting, this is not important, this is not also using. If you can read this, you will understand. Now I am going to thrashing. Thrashing is nothing but which has no more number of pages faults as a situation. CPU will be more saving, like there is a p1 p2 p1 and p2. There is a page. If p1 and this p1 and there p1 page 3, p1 page 2, p1 3, and p2 page 1, p2 page 1, like that. So this will be always less overhead, and it's more overhead because of p1 process 1 page 1, process 2 page 2, like that. So it's always be overhead in this case. It's basically saying that cause of you can also read this. If the process does not have the number of frames it needs to be support pages, it active issue quickly. Page faults at this point must be replaced some page. However, since all the pages are inactive, so it must be replaced page that will be needed again right away consistently. It faults again and again and again, replacing pages that mean must backing immediately. So if degree of multi-programming is increase, then thrashing also increase, like that it's saying that. Technique to handle thrashings, there is a working set model and a page fault frequency. This model is based on the concept of locality model. The best principle state that if you allocate enough frames to a process, accumulate it current circulate, and it will only fault whenever it moves to some. You can read this. And thrashing is a high page fault rate, we can control page fault like that. If you, I have like this is the thrashing, through this we can control thrashing. I hope I have explained you very well. So you can read this also, so you can understand what is cause of the thrashing and handling, like that, so you can understand. So this is the last video of operating system. Now I'm going to explain my notes on computer networks. So yes, we have completed operating system. Thank you for joining me and learning together. So we will going to learn computer networks. Okay, till that time, bye.